Richard Proctor. I'm the General Manager for Healthcare for Hortonworks. And we've got a couple of speakers, but I wanted to kind of set the stage because we're going to be on kind of two different paths during this session. So first we have Dr. Mary Kerr, and she's the founder and director of, the Kerr Institute. The greatest name for a doctor to have is Kerr. So she's going to kind of tell a story of how traditional medicine that she was practicing for years and years and years kind of changed with some of the new regulations and some of the new availability of data. And so she's really been practicing precision medicine for quite a while before the name was even, in the popular nomenclature that we have today. And then we're going to kind of switch tracks and go from someone who owns a private practice and how they're dealing with big data and other data sources to Dr. Roy Wilds. And Dr. Wilds is the chief data scientist over at Feeney, and he's going to talk about the Molecular U program, which is the goal is to give 20,000 participants over the next 5 years a molecular understanding of themselves. So we're kind of going to go from small to big and see how different entities are dealing with new data systems, data storage, processing, and I'll hand off to Dr. Kerr.
Thank you. Can you hear me okay? So we are entering a new era in how we practice medicine, and that is due to the utilization of data in the daily practice of medicine, and the data particularly that comes from genomic testing and these advanced tests that we now have available to us. So it's really a fundamental shift that's going on right now, and I believe that it's the future of medicine, is that we are going to shift from a reactionary treatment of symptoms to a system in which we help patients not only prevent symptoms from ever occurring on a personal level, but we also help our patients achieve vitality, better mental function, better productivity, better weight control, lower risks for morbidity and mortality across the board, using this data that has just recently become available to us. So it's a very exciting time to be practicing precision medicine. So I'd like to talk to you a little bit about my path to precision medicine, which is guided by data. It starts, my history is, I come from 5 generations of physicians out of New Orleans, and this is my great-grandfather's logbook. So this was his data. He didn't even fill up, he goes to page 20, and it's dated December 18th, 1911. And he basically practiced one-size-fits-all medicine, and his data came from basically recipes or nutraceuticals, and then the data that he could achieve by talking to his patients and his own inspection of the patients. So fast forward, when I was in med school and I graduated in 1997, we were still practicing this type of medicine, even though it was more advanced and we now had more pharmaceuticals, but we were still basing our decision on one-size-fits-all medicine, and there was no personalization of our treatment plans. So I completed a double residency in internal medicine and physical medicine and rehabilitation, and for about 10 years I got a lot of satisfaction out of helping people manage their symptoms. But somewhere along the way, I started to realize, as I learned more and more about our potential, that just managing symptoms isn't good enough. It's not good enough for our patients, and we need to find a better way to achieve optimal health and vitality. And as we're living longer, it's even more important that we are able to achieve this. So I completed a 2-year residence fellowship in anti-aging and regenerative medicine, and I transitioned my practice from pain management into wellness. So again, it's like in the past it used to be one-size-fits-all key, the same key for every lock. It kind of looked like the right key and it slid into the lock, but it didn't quite turn for everyone. Now we're making a custom lock for every single patient that I see. No two treatment plans are even remotely related because we're using data to individualize it. Right now, the way this data is interpreted, it's coming from dozens of different sources, and it's really being processed in the minds of physicians who practice precision medicine. So we don't have a lot of ways to incorporate these different sources of data and look for trends and analytics in a safe way. And there aren't a lot of us doing it, but I believe over the next 10 years, you'll start to see the transition from traditional allopathic medicine into this type of medicine, which has several different names, such as functional medicine, anti-aging medicine, precision medicine, integrative medicine. So where are we getting all of this data? And the slide isn't showing. Let's see if I click it again, if it'll show. Yeah, it's coming from just dozens. This is just a sampling of where I'm getting my data for my patients. It's coming from genetics, direct-to-consumer genetic companies such as 23andMe. It could be imaging studies, wearable devices, biomarkers, nutritional studies, micronutrient testing, testing of the microbiome, which is the bacteria in the digestive system, toxicity for heavy metals, and they're all coming from different labs all over the country and sometimes even from Canada. So now I obtain all of this data for my patient, and I sit there and meticulously go through every study and come up with a plan in my head. The problem is we're not collaborating with other physicians as much as we could be. We're not learning from other people's experiences. We're really just kind of trailblazers out here doing the best that we can. But I know that with the help of technology that we have the ability to achieve so much more. So with all of this data, and it's an enormous amount of data, we also have enormous potential. And so I'm going to share with you some examples of how it's had a huge impact on some of my patients. I've never found anything that was more motivating for positive health change than genetic data. I can tell you your cholesterol's high, but if I tell you you have a gene that gives you a higher likelihood of Alzheimer's, that's very powerful for change. And my patients listen when it's about them. They're not just a number or a risk factor. It's actually their DNA that is guiding my treatment approach, and we have much more success in this individual approach. The potential to save healthcare dollars is unbelievable. We can eliminate a trial and error type of medicine, an unnecessary diagnostic test, by figuring out what is the most likely cause of this patient's symptoms, or what is the most likely reason why this person would have problems in the future. And we can avoid those problems, and many times in very simple ways, such as nutrition, exercise, but targeted towards that individual's strengths and towards that individual's risk factors. So we can actually prioritize our health goals based on these sources of data, which include the biomarkers, hormone levels, genetics, and the list goes on. This is an example of my son. So he's now 6 years old. Right about the time that I was learning and incorporating a lot of DNA data, my son was born and started having some pretty serious health problems. I took a cheek swab and sent it to one of the reference labs that I use, and his symptoms were pretty dramatic. He had eczema that was so severe it was bleeding. He wasn't sleeping through the night. He had digestive symptoms. I wasn't getting any sleep, and we were facing some pretty scary diagnostic studies, such as general anesthesia, colonoscopy, biopsy, multiple different imaging studies, radiation. So we're trying to figure out what was wrong with this child, but by getting his DNA, I was actually able to learn that he had a very high likelihood of being sensitive to gluten, and by taking him off of gluten, his symptoms improved dramatically in a very short amount of time. I also learned that he had a deficiency in vitamin D, and by simply replacing his vitamin D levels, he improved a great deal. So it was something as simple as just nutrition and vitamins that actually had a huge impact on his outcome. And he's a perfectly happy, healthy, normal little boy now. And imagine the overwhelming relief for a mother to know that she was able to target therapy towards her own child. There was no trial and error at his expense. We actually were able to give him methylation support, which was another issue. And just by these simple steps, we made such a difference for him. So 25% of our population is affected by serious mental health issues such as depression, bipolar disorder, schizophrenia, anxiety disorder. I'm sure that everyone in this room has in some way been touched by mental illness. And up until now, we've been treating mental illness with a trial and error process using mostly pharmaceuticals. I want to tell you the story about a lady I saw in my office yesterday who struggled with anxiety, depression, and an eating disorder in which she's been hospitalized and has been completely resistant to treatment. We did genetic testing on her, and we started her on a customized treatment plan that was specific for her. We knew that certain drugs she would react very poorly to, and we knew that her body needed certain things according to her genetics. By making a very simple change in her diet, we were actually able to give her relief for the first time in her entire 56 years of life. She burst into tears and was so overwhelmed with gratitude and joy that she was asymptomatic and just doing beautifully after only a few weeks of this targeted type of therapy. So this has enormous potential. But how do we keep it safe? My patients are afraid to do this without being anonymous. The laws are somewhat ambiguous. You are not able to discriminate on genetics based on a person's for health insurance, but for life and disability insurance, you can be turned down based on your genetics. So people are afraid of this information being out there, and the information is going through search engines online that we hope are safe, but don't necessarily meet all of the requirements, and certainly don't incorporate into our electronic medical records. So there's a huge problem with this data and how we learn about it and share it, and how we use it to motivate and inspire our patients. So with all of this information, there will always still be the human interaction that is key, that we need to still touch our patients, encourage our patients, give them the information that will help them achieve vitality and achieve the most out of their lives. And this is the future of medicine. It's coming very quickly. There are exciting things ahead. And I believe if we can just find a solution to collaborate and share this information, that we'll be able to achieve unbelievable results in the very near future. So I'm going to pass it on to I'll let you talk about hopefully the solution to some of these issues that we're facing. And
excellent, thank you.
Thanks.
Cheers. Excellent. Pardon me. So good evening, everybody. Thanks for sticking around for the last session of the day. So I'm going to walk through basically an approach, a partnership that Feeney has engaged with a company called Molecular U based out of the University of British Columbia around trying to solve some of the kinds of problems that Dr. Kerr just described and really scaling this up to start to solve problems at a population level. And a lot of the problems that we solve at Feeney Systems are really around how you share data, how you manage data at scale. And I'll talk a bit about the technology we built on top of Hadoop to make that possible. So Dr. Kerr gave a great example and a great background on a lot of the problems and a lot of the challenges, the types of data involved in working with this new breed of data, if you will. So this is some of the data that the Molecular U Corporation, part of the Personalized Medicine Initiative there, the PMI, is collecting and working with. So the idea here is as she described, to basically establish and collect and have available a more complete profile of individuals and then use that data to help tailor specific care for them. And again, with a wellness initiative, the idea here is it's way better if you never get sick in the first place. If we can promote or prescribe treatments or different types of behavior you should be adopting or adapting to, that's a much more effective way of making sure you're healthy. And the side benefit is that this costs us as a society, in terms of healthcare dollars, a whole lot less across the board. So the Molecular U program basically starts with a whole exome sequencing up front, and then every 4 months they collect a bunch of information across the spectrum here. So we're talking about activity data, we're talking about proteomics, lab panels, microbiomics, so that's taking your gut and actually doing analysis of the bacteria that live inside of you, bunch of vital signs, bioinformatic analysis of this data. So basically, oodles and oodles of data. Richard talked at the start about the goal to grow to 20,000 individuals over the next 5 years. That's going to be in the realm of petabytes of data. And the guys running this, the precision medicine initiatives, and Dr. Kerr herself, they're not big data experts, right? They're not the ones that are going to be building the infrastructure, building the technology to make this possible. And healthcare organizations do not want to stand up a 100-person IT team to be able to make this happen. So at Feeney, we really focus on building tools to make this possible so that you can efficiently benefit from what Hadoop can offer without having to worry about having to build a lot of this stuff yourself and putting all the pieces together. So this goes across the whole spectrum here. I mentioned most of these to start with. Basically, Feeney partners with Molecular U Corporation to basically solve the data storage and processing and availability and sharing aspect of this. So this group it's kind of like a crowdfunding approach. So they work with a bunch of other researchers, cutting-edge labs that are doing the types of research that are going to find the patterns in your data that are going to help to inform what you should do, types of behaviors you should change. And that they want to be able to do is, as a whole, as a company, basically enable that sharing of data so that I can collaborate with people that are in different universities, I can collaborate with other departments, and not have to worry about the issues of how do I make sure data is being protected. As Dr. Kerr mentioned, this is sensitive data. People don't want their data floating around, being emailed around as attachments or other common practices right now, to be honest, in terms of healthcare, how we share data across organizations. So this is the kinds of problems that we're trying to solve. So briefly, this is the data dilemma problem. Any of you coming from healthcare and a variety of other industries too, this is the challenge you face, right? Data is siloed, so how do I bring it together to actually do something correct with it? And at Feeney, we were founded 3 years ago. We saw an opportunity with Hadoop and with big data technology to start solving some of these problems. I'll have a slide in a little bit that gives a better context for it, but this is the 10-year anniversary of Hadoop. How many of you guys were using Hadoop 10 years ago, or 9 or 8, 5+ years ago? Yeah, I know those guys. Yeah, okay, a handful of people. Do you remember when we used to actually work with unstructured data? Do you remember when it wasn't always just about put it in a staging place and then make a Hive table out of it, or whatever your choice of SQL was? This is the opportunity here around precision medicine. This stuff doesn't fit into tables. It's massive in size. You have to do a lot of contextual processing of that data to eventually arrive at something that likely will be a table. But to get there, you need to be able to track how you've done it. You need to understand where it came from. And these are the kinds of challenges that we're using big data technology to solve. Right. Just the last piece about privacy, security, and governance. There's been some wonderful talks here at the conference this year talking about encryption, talking about Kerberos, talking about Knox, talking about Atlas. All terrific steps along that path of solving these challenges, but in healthcare with health data, you don't get started unless you've got this figured out. You might be able to do a pilot, you might be able to have a small system going, but you don't get to roll anything out if you can't be able to say that, yeah, it's encrypted at rest, yeah, I can audit who's been touching this data so that if a patient comes along and asks a question about who's been working with my data, I can answer that, or if my compliance officer comes along. Sadly, there's data breaches all over the place in healthcare. You need to be able to track the history of your data if you're going to have a system that's going to scale and be successful. And this is where we focus. I won't go too much into the vendor pitch aspect of this, but basically we are built on top of Hadoop, on top of HDP. And what we've done is we're not just an accessory that runs on top of Hadoop with Feeney. What we've solved is the problem of how do you manage data lineage, data governance, data sharing, data provenance, and make sure you can find and work with this data as it's progressing through your Hadoop system. So there's tools and projects that are out there that are solving these problems. They're along the way. When we got started 3 years ago, there was very little. And so we built a lot of tooling, a lot of scenarios around here to solve these problems within a healthcare context specifically. And at the same time, we're trying to integrate with what's the best of breed, if you will, within the Hadoop community. So if you want to write Spark jobs to run on top of our platform, you can. And you can be guaranteed about having compliance in terms of knowing who's worked with that data and being able to determine if they should see PHI, for instance, or only decrypted version, or sorry, de-identified versions of data. Trying to really benefit from some of the best out there. NiFi is a big topic at this summit here too. We're looking at integrating this into our product as well, so you can flow data into it as well. But again, solving some of the problems around how you store and manage this data is one of the key things that we're working with. And again, at the bottom here, to stress this, we're really trying to do this for all the types of data. The one thing that you can count on is that the diagnostics and the tests that are powering precision medicine today are going to be different 6 months from now, are going to be different 16 months from now. The space is moving at a phenomenal rate. You've probably all heard about how it's now less than $1,000 to sequence your genome. There are other tests coming along. The microbiome is the hottest space right now in terms of the personalized medicine space around the omics or the molecular U aspect of things, and we're just getting going into it, and there's a ton of things that are going to happen there, and you want to be able to deal and adapt with changes in those data formats. The one thing we encountered that's a bit of a barrier is people end up trying to shove stuff into tables. And that's great if you're at the point at which a table makes sense for you to be able to work with data. But if you do it too early, you're back in the old problem you had back with your MySQL or with your Oracle database, right? Changes tend to propagate and mess everything up above that. So you want to be able to deal with those kinds of situations with a technology designed to work around that. Oh, a little too fast. Right, so some of the challenges we find within, again, working with healthcare data, I mentioned this, I won't spend too much time on the slide, but basically these are the things you want to be able to do easily. So Hadoop does some things really well, right? Like Hadoop does distributed storage, it does distributed processing, it flows data around, it's got resiliency, it's got failover, it's got scalable, economically scalable features, but it doesn't do a lot of this stuff. So being able to find things and index them, that means someone has to be clever about how you're going to design a schema, or how you're going to structure your key value pairs in HBase or Accumulo, how you're going to structure your Kafka consumers to feed data and load balance it into everything. How are you going to make sure that as you're transforming an echocardiogram or a brain MRI, and you're annotating that piece of data with extra data, like you're pulling out measures or metrics from that image, and then eventually someone's going to run a result or an analytic on that, and then some doctor's going to say, show me the MRI. They will. They all do this. You need to be able to make sure you can track back to where that came from, otherwise they're going to throw up their arms and say, I don't believe it, I don't trust it. Not always, but sometimes. And the last piece, privacy, security, governance. If you can't show an audit trail, if you can't show all the different pieces that guarantee and give peace of mind, no one gets to use the data or gets to use the system. So how do we do this? So we use metadata. And metadata is one of those terms that really means different things to different people. So coming from a traditional relational database world, metadata means information about your columns, your tables, and the constraints that go across those things, right? So can I understand what my fields are, what my columns are, the types, things like that. Again, with that whole idea that 10 years ago, Hadoop was about processing arbitrary, complex, structured data, we took the approach of trying to introduce a concept of metadata meant to deal with that description of data. So we work with data at a binary, asset level, if you will. So being able to describe the things you actually store, not having to put them into tables to be able to understand and describe those assets. So some of these things are, for instance, where did it come from? What's the retention policy around this? So I know what to do with it. Is it PHI data? Is it sensitive data? Is it public data? Working around how to back it up, data sharing agreements, et cetera, et cetera. So why does that matter? So I talked a little bit about why this matters. So it matters from the point of view of you need to maintain chain of custody, lineage, if you will, in terms of understanding where data came from because someone might ask you for it, or maybe it's part of the service you want to deliver on top of this, right? Like, at the end of the day, we want someone to use this thing to deliver better care. So in terms of the eventual dashboard or interface or search profile they're going to work with, eventually it's going to, under the covers, end up working with a lot of this information to determine what to do in terms of serving up data, showing a spike in a graph or whatever might actually be the end result that gets consumed. So we have the metadata to track the data, track that information within the system, and then we've got the context of our users. So I'm going to describe a little bit about how you control people to work with different data. So we describe the data, so maybe it's PHI, maybe it's from your hospital in Oregon, and you need to know that because only certain people can access that. And then you want to be able to determine, does Dr. Allen have rights to work with this? So the idea here basically is, okay, well, take all the information you know about Dr. Allen. Is he a real person? Is he a service? Is he a cardiologist? Is he practicing medicine? Or is he a professor at the moment? And take all that information and basically build a rule system that allows you to then control access to this. So if you've been if you've been attending the talks on Atlas or Ranger, similar type of idea. The idea here is you want to be able to use tags and rules and policies to be able to determine how people can work with data. And what we've done differently at Feeney is basically make this work for arbitrarily structured data. So you don't have to worry about having stuff fit into Hive to benefit from these kinds of features. You can have an image that respects this type of a control. So you can determine, can people actually access the image? Can people access the data I've pulled out of the record? Can people access the fact that I've got a mutation in TET2 that makes me at risk for specific types of leukemia, for instance, all of that type of scenarios. So at the end of the day, what does this give you? For us, the idea at the end of the day is that this makes it possible to serve up data under different conditions and different constraints and different environments so that you can then deliver services that are built off of that data without having to deal with the complexities and the security and the provenance and the lineage of that data under the covers. So the idea being here, you can store this data in whatever fidelity you want across all these different types of sources. You do your standard Hadoop stuff, right? You transform data, you make it, you curate it until it's in a point at which you want to then deliver it to an actual end person, whether it's a clinician or a statistician or the patient themselves, and then you want to make sure they only see the data they're allowed to see. That's the end goal here, right? This is what we want to end up delivering. And this is the kind of scenario that's powering what the Molecular U Corporation is working on right now today. Right, at least one architecture slide, and this is probably not enough detail for you guys. I'm happy to take technical questions about how we do this. How do we use Accumulo? How do we use Spark and Yarn and integrate these pieces together to make it happen? I really wanted to communicate the message or the importance of what's taking place in the healthcare space today. And for all of you in the crowd that don't currently work in healthcare, get involved with healthcare data. There are tons of repositories out there. If you want to work with open data, there's the Cancer Genome Atlas, there's the 1,000 Genomes Project. There are oodles and oodles of data out there. Actually, right now, the US has this PMI initiative, which is looking to recruit close to 1 million individuals to collect their data to make it available for research. Work with it. It's fantastic. How many of you go to see a doctor at least once in your life? Come on, yeah. Yeah, right? Ask for access to your data. Here in the US especially, you have the right to access a lot of your data under HIPAA and high tech. You have the right to be able to work with your data. It's fascinating. I'm assuming everybody in the room here cares about data. Maybe you're just a server junkie and you really like to work with stuff on the back end and build cool software and stuff, but if you're here at Hadoop Summit, and with the theme of data science and data analytics, this is what's driving the future. And so if you like working with data, get involved with healthcare data. Whether public stuff, whether it's stuff that's it's personal to you specifically, it's a fascinating space to be operating in. And we have tools to do this now. Hadoop is a wonderful platform to work with data at scale. You know, if you want to just spin up a toy cluster in AWS or Azure and start processing data and looking for patterns across different types of cancer genomes, you can do that today. You couldn't do that 5 years ago. And with that, we're a little bit early, so we have plenty of time for questions. Just briefly, if you have technical questions and we don't get to them here, either come grab us afterwards, or if you have questions about the care programs that Dr. Care described, please do, but otherwise you did see our contact information up there, so happy to take any questions from the audience.
How does precision medicine change the pharmaceutical industry?
Wow, okay, great question. So how does precision medicine change pharmaceuticals? So we know that for every pharmaceutical there's a risk associated. You hear them on the news, but what we can now determine is this on? Can you hear me? What we can now determine is if you're in the high likelihood of reacting in a negative way to this particular pharmaceutical. If you're, for example, I know that I can't take nonsteroidals. Advil. Genetically, I am sensitive. I'm likely to have issues with my kidneys should I take that particular medication? So we can customize which medication and prioritize which medication based on a patient's genetics, and what the genetics tells us is how well that patient is likely to metabolize that, and whether or not they're likely to accumulate toxic metabolization of the certain medication. So it's critical for selecting the right drugs, and it takes a lot of the trial and error and a lot of the complications out of using certain drugs. We know now that medical error, we can call it medical error when you give the wrong drug to the wrong person, it's the third leading cause of death in the United States. So we have the ability to save, God knows how much money by picking a targeted approach for the individual rather than trial and error.
And actually, if I just take that and roll it up one level, so in terms of pharmaceutical development, it's actually a fantastic space there too. So you guys probably have heard the statistics of it costs $1 billion to create a pharmaceutical drug. I think that number's not quite right, but on that order, in terms of the actual money that gets spent by Novartis or Pfizer or whoever else to develop it, by taking in genetic information and then doing modeling on top of that, you can actually start to predict which drugs are going to help to respond to certain individuals. So we work with a group out of the University of Florida, and basically they're able to actually identify, based on genetic profiles, which types of drugs may or may not work for individuals with specific types of cancers. So it's a powerful example of how, by taking into account that information, you can actually start to target how to develop drugs, because if your drug costs $10,000 per shot and you're randomly giving it to people that have this type of disease and maybe they're not going to respond and you could tell that in advance, you have a much better chance of success in terms of developing that drug.
Mm-hmm. Yes.
So this question actually has 2 points, and I think each point is for each of you respectively. But I guess my question is along the lines of using things like 23andMe, which are specifically labeled for research use only. How is it that you're using that in clinical care? Does that present barriers to entry? And along the lines of software, is that also CAP/CLIA compliant, and does it follow, is it FDA approved?
So we use things that are non-FDA approved all the time, and it is not FDA approved, but it is in our license and with our training. It is at our discretion to use information that we clinically feel is relevant. So right now it's really at the discretion of the physician how they utilize that information, whether it's FDA approved or not. But FDA approval is wonderful for educating, but when I find something that's not FDA approved that would likely benefit my patient, I simply educate my patient on what we know and the likelihood of it being correct, the pros and cons, and we call that informed consent. And we make a decision together based on the information that's available. And we are very aware that the information is changing every second, and that we'll be updating that, but we're doing the best that we can with the tools that we have, and we're doing a very good job achieving a higher level of health just with what we have now. I can only see that getting exponentially better in the future.
I think to the second part of your question, a lot of it depends on the specific scenarios, environments in which you're deploying. So in the case of doing research on data, obviously you do have constraints around what kind of data you're allowed to acquire and how you have to handle that. And what we're really trying to solve is the problem of making it easier to bring in data you want to work with, to then have it available, to share it, to solve it. Once it makes it to a clinical situation, you're absolutely right. You have to look at things such as informed consent and the proper regulatory regime there. But that's a bit of a downstream problem, if you will, from the software that at least we're focused on at Feeney.
And I actually get signatures informing patients when something's not FDA approved, and I save the informed consent in their electronic medical records. Yes?
Bill.
So I guess there's a lot of source data that has to be kind of governed and classified to make sure certain regulations are met. What about derived data? So if you were building, there's a lot of machine learning comes here. So I built some model to kind of make a decision about what someone may or may not be at risk for given a combination of factors. Are there a lot of rules for governing that? Like how does that get managed to make sure that potentially that's secure and not identifying people at some point?
want to take that?
Great question. So you hit on a couple of challenges there. So there's the whole problem of re-identification or identification, so in terms of data leakage, if you will, in terms of what you can infer from that. Maybe I'll defer that to the second part of the answer if I can. Around the first part of it, the most common problem we run into as far as governance goes is that example I started with where you need to be able to explain. Nobody likes a black box explanation most of the time, but clinicians really don't like a black box explanation, if I can put words into your mouth. You need to be able to explain why you've arrived at that result. Why have you given that recommendation so that you are at risk of type 2 diabetes? You can't just say you're at risk of type 2 diabetes. You need to say you're at risk of type 2 diabetes because of A, B, C, D. And so being able to track and have the governance of how you've arrived at that conclusion from the data you started in is a key requirement in terms of making that actionable. The worst thing as a data scientist, right, is that if you do some amazing analysis and you come up with a way of predicting some amazing concept and no one cares because they won't use it unless you can explain it to them. I've been there. I've had it happen. But that's a challenge to be dealt with. That's really more about the lineage and the provenance and being able to explain how you've arrived at that. And you can imagine as the sources grow, this is a problem that becomes a bit unwieldy in terms of, well, I'll just take my code and check it into GitHub and they can go refer to the pipeline that I put in there. It's something you need to sort of build in as a first-class characteristic. Maybe I'll defer your second question until later if we have other ones. Did you have anything you wanted to add?
No, I think you covered it. But really right now it's at the discretion of the practitioner to make the best informed decisions that they can possibly make. And of course the first rule is do no harm. And so we're selecting therapies based on, and we're prioritizing therapies based on their highest risk factors based on the data that we know. But there are a lot of genes that we don't understand that could potentially be overriding some of the genes that we do know are associated with risk factors. And then there's a whole nother realm, which is called epigenetics, which is the way the environment influences your genes. So you may have a particular gene, but the gene never gets turned on or off because of whatever environment you're in. So this is why, identical twins, some will have, if you're looking at a pair of identical twins, there's only a 50% concordance in if one twin has schizophrenia and the other. And that's probably because the genetic switch was flipped for whatever reason in one. They both had the risk factor, but in the other, it perhaps was not, based on their environmental interactions, their nutrition, even your thoughts can affect your hormone levels, such as cortisol, which can actually have an impact on the expression of your genes. So every thought, for every action, there's an equal and opposite reaction. That goes right down to energy and thoughts and positive thinking, and it actually is affecting the expression of genes.
We had one at the back, maybe, then we'll get to you.
Yes.
Yeah.
Considering all the data you have from things like maybe a saliva test, a Dutch test, a hormone test, to a 23-year result, right? What kind of tools are you using now to kind of sift through all of these results on a per-user basis?
Well, so the tool is my brain right now, and a 2-year fellowship and lots of continuing education because it's changing so rapidly. So I'm actually, there's a few of the labs that interface with my electronic medical records, and I can actually watch trends, but they don't talk to one another from one lab to the next. And so oftentimes I'm getting paper copies and going through it the old-fashioned way, the way I learned, and coming up with a plan based on the information at hand. Where the exciting thing is going to come in is when we start collaborating and looking at all of this data and trends and how they interact, and really being able to give a patient a much better answer of you're at a high likelihood of this in the future. And hopefully one day we're going to be able to alleviate a lot of unnecessary surgeries, such as preventative mastectomies for people who are at risk of breast cancer, because we know that they have it in advance, and we take certain measures so that those genetic switches don't get turned on. So we can hopefully make a huge impact on the expression of those genes quite early on. And I think it's in the not too distant future, every baby will be sequenced, and the parents will have the opportunity to strategize on how they'd like to nourish their children, right down to what sports they're most likely to be good at, and how to make sure that they achieve best brain function in the classroom, and the list goes on and on. So it's very exciting where it's going.
I want to come back to that machine learning question, because I think that's an important point, because a lot of developers will, they're engineers. They want to address the problem. They want to find the best tool to address the problem. But the result's actually quite a bit different than a genotype-phenotype relationship that we can comprehend. We can say, oh, okay, so I understand that study, there was 10% of the people that had that variant also developed X, Y, and Z, and we can rationalize that in our brain. So I guess my question back to you is, given a machine learning output, which it doesn't have very discrete, I don't know, I'm not a machine learning guy, but just from my understanding of machine learning, it is essentially a black box. So how would you feel comfortable as a practicing physician taking a result from a complex algorithm and applying that towards your patients if it's not discretized in such a way that you can't really explain why it is what it is?
So with the limited data that we have now, we're already just trying to categorize risk factors based on likelihoods. Nothing's definite because of the whole interaction with the environment and the phenotypic expression of the genes. So basically, I'm looking at the patient's symptoms, their history, perhaps vitals from wearables and imaging, and really getting an overall picture, and then looking at trends of what the most likely etiology of whatever symptom they're having is, or the most likely cause of a problem in the future. And so we're strategizing based on the information that we have, but nothing is black and white. And we are having tremendous success taking this approach as opposed to a trial and error approach. So it's much better than we've had in the past, but it certainly needs a lot of improvement.
Looks like our time is up, but yeah, we're happy to take a few questions up here or mosey on over to the showcase. So thanks very much, everybody.
Thank you.